Hi and welcome to week 4, working with servers. In this week, we're gonna launch an MVP, a minimum viable product. What this means? Well, we want to launch our application on a server. Let's see the assignments. We have to create a custom AMI using Hashicorp Packer. We have to configure the custom AMI using Bash. We have to launch an EC2 instance based on the custom AMI using Terraform, and then manage the EC2 instance using AWS Systems Manager. Now, first of all, you have to create an EC2 instance and then connect to the instance and start to build your application. This is the normal basic way. But what we're trying to achieve here is create a custom AMI. If we do that, every time we will want to launch an EC2, we just select the custom AMI based on what we created, and when we launch that EC2, it will just give us the application. It will launch the application on the server straight away without the need of configuring anything. And why should we use this? Well, just because if you want to scale, if you want to launch a second EC2 or another EC2 in another region, if you try to create your application from the beginning on the server, once you are connected to the server, that means on the second server you will have to do the same. And then if it takes you about 2-3 hours to do that, just imagine when you have to do for 10 servers. And you might just do mistakes when you go from one instance to the other. That's why it's really good to create a Packer image and then use that Packer image, that AMI, and based on that you build your servers. Now, the other ones, the configure the custom AMI using Bash, is just what I'm talking about. That's how we configure our Packer image. Let's see the architecture of this. So this is the architecture. It's me who will use VS Code to create a Packer file, and the Packer file we have Django, PostgreSQL, Nginx, and GUnicorn. Everything it will be created in that Packer image. And also in VS Code, I will create the AWS infrastructure, EC2, and everything else. And as you can see, I have two GitHub actions. One will create the Packer image, and then the other one will create the EC2 instance using that Packer image. And as you can see, I can use the SSM to connect to my instance and manage the instance as well. Now, let's go through the Packer image just to show you what do we do and how we build it. The first block is the Packer block, where we have to put all the required plugins. Then we have 3 variables. One is for version, and this is how we keep track of our versions. Well, with AMI you can change it. So you launch an EC2 based on one AMI, and then you want to improve your application. You just modify your AMI, and then that's how you keep the track of every changes you do by assigning some versions to it. And then just in case you have one AMI which is not working, so you create a new feature and that's not working, you can just use the previous AMI to run the application again. And that's how you have your application up and running, just in case any of the features don't work. Now, as you can see, we have the subnet ID and VPC ID as well. They come from the networking account which we created in week 3. If you remember, in week 3, we had to create a networking account and a VPC and a subnets and everything else what's about networking in that account, and with that account we just shared them with all other accounts. So these are just to refer to the subnet ID and the VPC ID from that account. And we have the locals, the AMI name, which is group startup, Then the source AMI, this you can take it from AWS console. The source AMI owner, the same from AWS console. And then SSH username is called Ubuntu. So when you want to connect to the instance, which is created from an Ubuntu AMI, that's how you connect to it using the Ubuntu username. Then we have the source. In the source, we have the name of it, the type of the instance we want to launch, the region, tags, and few others specifications. In the build phase, we have the name, the source, and this is the source, the basic source which you will build the Packer image, the AMI. Then provisioners. What I have to tell you about provisioners, you have to keep them in order. You cannot run few other commands before you update the virtual machine. So we always want to keep the latest updates for our virtual machine. Then with the provisioner file from the directory, the main directory, when we connect to the instance, we are in the main directory, we want to copy everything from there to the TMP files. In the next provisioner called shell, we just move some files from our app to the TMP. And then in the last one, we just run the setup.sh. And this is the file created here. Now I'm gonna run through this just a little bit later. And the last one, but not the least, is the post processor, where we have to specify the region, we have to specify an identifier, and keep releases. Now, why do we want to keep only 2 releases? Well, just because we want to save money. So in case you keep more than 2 releases or so many, like you don't put a stop to how many you want to create. Let's say you create 10 or 20, that takes space from AWS and they will charge you. But if you only keep 2, you will stay in the free tier. Now let's have an overview about the setup.sh. We have the app underlying dir. This is the main directory of our application. We want to give Ubuntu ownership about that file, so Ubuntu user can do anything in that file. We just install, update Python 3 and everything else we have to. Then we enable the PostgreSQL, and then we create the source from the secret, and this is the secret.sh. That's the source of our application. We create database and many other things. You can just run through this file and see it for yourself. Now what I want to add to this is, as you can see, sudo is used as super user do. That's used when you are restricted by some things and you can't run a command. But then that's not the best case always. For example, when we try to create a virtual environment with Python 3, if you use sudo, that means you are the super user and you will create some files in another directory which you are not meant to. If you create this virtual environment with the Ubuntu user, they will go to root, like this is the folder, root, and that's where you will create that virtual environment, and only that way you can have the up and running as you should. Now, as I mentioned, you shouldn't always use the sudo, just in last case scenario, if you don't have the necessary permission, you will just use sudo, but for anything else, just try to use the normal permissions. Now here, as you can see, we just create the JUnicorn service and everything else. And then we just restart the Nginx, we give permission to HTTP so we can connect to it, and we are good to go. Now, as I mentioned, I have 2 workflows in GitHub Action. This one will just create our image, and this one will just create our Terraform infrastructure. In the Terraform infrastructure, we have the data, which is the AWS AMI. So what we do here is we take the data from the AMI we just created with the first workflow, and we use it to create this EC2 instance. We have the EC2 instance and some security groups. We have the IAM role. So we created an IAM role. So we give permission to GitHub Action to connect to AWS. And then we have the providers and the variables. And that's pretty much it in Terraform. Now let's see the demo. So I run the two GitHub Actions before. This is the one which will create our Packer image. As you can see, it was just rerun 8 hours ago. And then the second one, the app deploy, I just run this to create another EC2 image. And what I usually do with this is, if you go to action and you press on app deploy, you will have to run it manually. And here you will have to specify the version of your AMI. And this is really cool because you want to choose so you want to launch any instance based on the AMI you want to choose. Now let's go to the console. We have one instance running. And by the way, if you run the first one to create a Packer image, and then the second one, here you will have two instances, one stopped and one running. The first one is stopped because when you create an AMI image, what it does, it comes to AWS, it will create an instance, it will create the image based on that instance, and then it will stop the instance. Now let's see if we can access our application. We copy the public IPv4. We go to the browser. And we just paste it. And there you go, it works. And let's see if it truly works. We sign up for it. So let's just create a user test. Let's generate random password. Random password 123. Then password 123. And we register for it. And there you go, we are logged in. Now we choose a name for our file, a description, test super image, and now we choose an image. And we just upload it. And there you go, it works. So just in case you forgot, we had to create an application for our CEO that you will be able to upload pictures on the website, and you will be able to see the pictures whenever you want. Now let's see how we can connect to the instance. We just select the instance, we go to Systems Manager, and we just press to connect. And this is where I set up the whole commands for that setup.sh. If we just run bin hash, you can see we are connected as the SSM user. Then we sudo su. We can just log in as the Ubuntu user. If we run this command, here we can see all the files created by me in this application. And that's it. This concludes our demo for this week. Thank you very much and see you next time.